Hello, my name is Victor Lopez. I work as a developer for the localization of enterprise source planning software. I'm going to talk today about the process of developing a language server with the Rust language. So the main topics will be, I'll first describe briefly the language server protocol, then I'll talk about the Rust language server, that's one implementation of it, and then I'm going to talk why I choose Rust and how's the process of developing this solution with Rust. So first, what's the problem I had? I have a proprietary language called ADVPL. It's a property of TOTUS, and it's consolidating in Latin America. But we're bringing a solution to Russia, and we don't have developers with it. So we need to provide a solution that will support these developers. And this solution should provide the possibility to integrate with external components like the one application server that will communicate with some object storage. The current protocol we are using for this communication is REST, but could be any. We can just implement on the language server and extend it. And also check on the database some information about the process of development. This was the challenge. And also, we work with multiple IDEs. We have one Eclipse-based IDE that's called TDS, and one extension in VS Code. So for this, we cannot, for every implementation of the language server, make one additional requirement on the solution for the language support. And also, the last challenge is the interaction with external objects. It should be easily implemented, and we can achieve this with the language server also. The language server protocol, why it's good? It's totally agnostic if we talk about the editor we are using. So it means that it will work with VI, with VS Code, with Eclipse, or whatever supports this protocol. And the definition is open and very clear. So it's open source work. It's very robust nowadays. A lot of people is using. So we have some fairly good results with it. And it's broadly used. We have the major languages using this protocol for their implementations. And with this, we have a lot of situations already covered, so you can count on this framework. It's totally extensible. That's a necessity we have with this particular implementation to extend the functionalities to integration with other services. And we have the classical M times N problem for the language support development. It means that, like, if you have a given language, you provide a functionality to support this language. You have to implement this functionality for the number of editors you are going to use. Instead, with the language server, we just implement the functionality. I'm going to give a very quick demonstration on how it's working. Here's my terminal here. So, here on the left, I have an implementation for the VS Code, and on the right, I'll show the output that goes to the language server for every request we make. Here, 1 second. So I'm just going to tail the language server log. Okay. And on the right, I'm going to perform some operations with it. So we're going to see for every operation performed by the IDE, a communication based on the JSON RPC protocol to the language server. I'm just dumping the information on the terminal. So here we have the hover, some linting with the... I'm encouraging the users to use single quotes in this case. If we, for example, create a new file, let's put the language as this one. And I'm going to write here a classical hello world. We can see all the interactions of the user with the IDE. Like being outputted on the server. So going back to the presentation, I'll show briefly the architecture of this solution. Let me just close this. So, about the architecture, it's on the right. It's everything JSON RPC based. So for every interaction, as I showed to you, we will send a request to the language server, and we'll expect a response. If the request type is request, or you can just work with notifications. Like if we open a file, we expect no answer from the language server. So it's a notification. And if we ask for a command, like the linting command, we should expect one response. Language server, who is using? I bet all of you know at least 2 or 3 of these logos. We have some very big implementations for this protocol, like either for the editors like VI, JetBrains, or Eclipse Foundation. And on the right, we have the Rust language, we have the C++, Java, Go, and so on. About the perspective for the language server protocol, we see this as a possibility of bringing every of the support of languages as a service. In this example, I have an implementation from Eclipse that's called Che. They support on the browser full IDE. You can easily implement language support on this with the protocol if you just provide this extension to them. So we have a fully integrated environment. You can debug, you can communicate with external services, you can run tests with some Docker. So it's quite powerful, and it's currently available. We also have the possibility of using some language telemetry. This means that if we're going to change the behavior of the language, like for Rust, for example, we're introducing the 2018 Rust with some breaking changes, like the async keyword. We could understand which projects are using this keyword and somehow interact with this problem. We also have some possibilities on CI that we have the current paradigm as a test-based, but we could interact with some, for example, static search analysis. And also, we have the possibility of using some domain-specific languages to implement language servers. So not only for the developers of systems, but we could also specify the documentation of a company or any other, even natural language with this support. Here we have one implementation in Rust that's very good. They presented this on Rust conference of 2016. It's called Xi. I really like it because I'm a big fan of VI, so somehow have this match on the name. It's fully implemented in Rust, and they only implemented the backend. It's somehow supported by Google and open source as well. And they have one very strong pillar that's the performance. So everything is asynchronous on the base of this particular backend. It's fully open source, and there are some demonstrations on the GitHub of this editor about the speeds they can achieve with Alacrity. Alacrity is another Rust implementation for terminals, uses GPU, and it's fairly good as well. And we have also one Rust implementation for the front end that will communicate with this editor that's called GXI. It's based on GTK, and also open source. The GitHub is there for the ones who are curious about this. So as for the major supported editors for the Rust language server, we have one resource called Are We IDE Yet? For the ones that are familiar with the Rust community, we know that there are several resources like this, like Are We Game Yet? Are We Web Yet? And this is for IDEs. We have a follow-up of the functionalities of the editors there, and what are the expected implementations and so on. It's quite interesting for the ones who want to take a look. My personal selection for the major players is Eclipse Corrosion, that they provide support for Rust. VS Code also have some set of extensions. VI, they also have fairly good support. It's my choice. And JetBrains, they are not the Rust language server user, but they are implementing a support of their own to this language. So this was their decision. I flagged here as a not RLS user, but they are it's fair to mention them because we have a lot of users, and it's a major player, absolutely. For the completion, we have the racer. It's an implementation to provide completion and work in parallel with the language server, so they both will work very well together, especially for the new Vim implementation, in my opinion. And also, we have the GitHub that's open source for the language server itself. It's always on the bleeding edge, so they follow everything that's new on Rust, and it's working currently on a very stable state. The recommended setup for beginners, in my opinion, is VS Code with the set of extensions I highlighted there. It's fairly the same as in the RWE IDE yet. And for VI users, I use particular this set of extensions that you could easily install with, I don't know, Vand or any other installer. And they will provide a very good environment for you to develop your solutions. About the Rust language server, how to collaborate. They follow a very normal community approach to bring maintainers and people who are willing to contribute. And for the ones who are beginning with Rust, there is also always the good first issue labels that based on some analysis of the community, some issues that could be easily understandable for newcomers, and they can tackle on these particular subjects. We also have the VS Code extension that's also open source, so you can just fork the repository and start to work with it. And the problem about the Rust language server that we don't have huge test coverage. So if somebody wants to contribute with that and implement some test coverage, will be awesome as well. And of course, we can bring additional clients. For every client, we need to have an implementation that will communicate with the language server. So in this case, if you have a particular editor that's not currently covered, you can just implement additional clients and it will be very helpful. And if you just use and report issues you find, you will also be helping. So these are the key ways to collaborate on a helpful way with the community. So first of all, why Rust to develop this solution? Performance is a strong point that everyone always talks about Rust, and I'm going to show a quick demonstration to some proof of concept I made to define that this is actually okay for what I expect. It's cross-platform, so I don't have to change the code to make it available for Mac, for Linux, for Windows, or whatever. So it's very, very simple to make this cross-platform support. It's out of the box. And this was also another very strong reason if I'm talking about providing support for different countries, for different editors, we need to be cross-platform. Safety is also another very strong point for Rust, so I never found any weird memory problems, so it's a fairly good point as well. And one of the most important is that modern technology is friendly. This means that I have this idea of bringing the community together to provide some linting rules and some solutions that will actually require some involvement of the community. We talked previously about the WebAssembly solution, and I developed a parser that will work out of the box on any browser, any modern browser. And this is one of the possibilities we have with Rust. So out of the box, I can provide this type of support and follow any modern technology paradigm. We have available Pest framework that uses some PEG grammars. We'll talk a little bit about it later. And we have one ready crate called language server types. They will provide the specified types for the language server communication, also out of the box. So it's very simple to be adequate with the implementation. I found one little bug with the Eclipse integration based on this language type, based on some required and not required fields, and it was very, very simple to use this as a base to declare that. So here, I have the proof of concept I talked about. I developed an NQueen solution. It's a classical mathematical problem that they have some fairly extensive computational power required. So I'm going to give a very simple example here. I'm going to set, I don't know, 15 rows queen, and I'm going to ask them to solve this. So, like very fast time, we can solve a complex problem, like in 10 of time, like I say. And this is was the proof of concept that for a computational power that I require to make this language server and parsing online available, I could easily fix with this. So I implemented as well sort of compiler that's browser-based, is totally WebAssembly-based, is open source for the ones who want to take a look. And here, for example, I have one expression, I will just parse it. Let me introduce error on the syntax, something like this. Ah, okay. So, for example, if I want to produce a compilation error, there will be the parser output that this character is not expected on that position. And if I fix it, I have the full parsed tree on the right. So this works very fast as well, and it's totally browser-based. Currently, I'm offline. So going back to the slide. So this is why I choose Rust. So why the Pest framework? Why PEG grammars? We have open source solution as well, the Pest framework for the development of parsers. It's on a very stable state now. And for the resource demanding operation of parsing sources, I have some examples like the one I showed before. That's like 2,500 lines. I have others with 10,000 lines, so they should be parsed fast. And I can achieve this with less than 1 second of parsing time. I can show later. It's a fairly good number for user interaction. So if we're talking about a complex operation with user, and we parse in less than 1 second, it's a good result. We could grant that we have these features with Pest, based on a grammar development. And these grammars, the PEG grammars that this framework provides, they are always well-formed. So I have some validations on Pest for the development of the grammar that will predict some left recursion problems. When you are in development time, you will not waste time in production to fix these very common problems. Also, safety is another topic for this one, another +1 for this one, and also modern technologies friendly. This framework in particular, because of the PEG grammar structure, it's very good to parse source code, but not good to parse some natural language. So if you're talking about developing a domain language that's somehow close to natural language, this is not your solution. I've put on the right a simple graphic about the performance of Pest compared to GNOME and CERD. GNOME and CERD are very well consolidated libraries in Rust as well. And this is the amount of megabytes they can parse per second of JSON data. GNOME is very, very efficient, but they are not grammar-based. So all these solutions that I want to provide, natural will not be available because I have to develop the parsing from scratch, something like that. So GNOME has a fairly good parsing time, and Pest, with the grammar-based development, can achieve a reasonably good number comparing to GNOME. We have like almost 200 megabytes per second when we are parsing JSON with this framework. The challenges of using this Pest framework that I faced. I have the multi-threading problem. So most of the things with the language server is asynchronous. And unfortunately, we don't have the send-sync implementations for Pest on the current state. I honestly expect this to be implemented on the Rust 2018 with the new features. But anyway, the way I had to fix this particular problem is to use some Arcan mutex to access the parsed tree on the main thread. So this was the way, and it's not a big problem since we're not talking about different developers accessing the same resource. We'll not have concurrency problems there. And we have an implementation from the Pest framework that's called AST. The GitHub is there, and they are using generic types to implement their parser. This means that we could easily implement the send and seek implementations on our types, After this stable, I'm currently not using because it's a very recent initiative, so I will finish my work with the native Pest, but there is also this possibility. If multi-threading is a big thing for you, you can go to this AST implementation. For the development of the grammar, if you're going to develop a grammar, you should expect a proportion like this one. This is my case. I have 400 lines of grammar, and I have 4,000 lines of testing, of TDD. Why TDD? It's very difficult to debug one grammar. At least for the Pest, we have the set of macros that's based on this other language. That's the syntax for the Pest grammar. And this was taking a lot of time. So I decided to take the TDD approach. And if you expect to achieve a result, you should expect a proportion similar to that in your effort planning. So I pointed here that we don't have clear debugging procedures for the parsing, and this will be one of the challenges certainly you will face. So about the execution of the development. All the communication between the editor and the language server will send some JSON RPC requests to the server, and it will have to manage the data. So for every character change, for every document open or any other interaction, the editor will just send the contents of this changed data to the language server, and it will have to store internally the contents of the sources you are working with. This means that you need to have some sort of implementation for the virtual file server that will be in memory. If we're talking about always parsing data from disk, this is absurd because it takes a lot of time and resources. So it's mandatory that you have some memory control for this. And we have the Rust language server solution for that already done for us. It's a virtual file server. The GitHub is right there. It's fairly stable as well, and you can use this as a base for your implementation. About the JSON RPC communication, I used the Parity tech solution. We have the JSON RPC protocol implemented there, and it works very, very well too. I never had problems with it. And they have several server implementations. So they have some RPC, some ACP. I myself use stdio. That's fairly supported by any environment we are talking about. But they also have some other possibilities for you in case you need. And some general guidelines I followed to achieve the result. Any change on the test of the parser will increment the major version. This means that we can, on a reliable way, count that the parser will always produce the same tree on a deterministic way for a given version. This is important for when you're talking about linting rules. And if you want to develop some strong linting rules, will depend on some community interaction. Maybe they will suggest rules, maybe they will suggest some analysis of your search. And if you have different parsers for the same version, it's totally not possible to consider this. So this actually follows the TDD idea. So any change on the test will increment a major version and will imply some possible breaking changes. And we also require a very strong participation of the community when we are talking about the linter rules. This means that for my particular implementation, I'm using some voting systems to integrate the contents of the rules, like the developers can give a +1, -1 for a given rule, and based on this information, we can define what's being accepted and what's not being accepted by the community. Like these lints usually struggle with developers, so maybe they will not be very popular, some rules, but anyway, for the ones that make sense, we can have at least this instant feedback of the community. Since we're talking about the language server that can communicate with any known web services, it's very, very easy to achieve that. So here I prepared some set of useful links for the ones who are curious about this implementation. The first is a guitar that I use to communicate with some guys that are participating with me on the development. And the second is the implementation with WebAssembly that I showed previously of browser parsing. The third is the Pest website resource. There you can find a very small book that will somehow describe how you can develop with this framework. Language specification, that's a fairly important resource if you're talking about developing this. And of course, the RWE IDE, the language server GitHub, and the JSON RPC from Parity Tech implementation. That's also open source, and you can use this as a reference. So in case you want to consultate to understand better how the communication with our language servers is working, you can check these contents. That's pretty much it. Thank you very much for the participation, and I'm going to be available on the lunch or around there for any questions you may eventually have.
Thank you, Victor.